Hello friends. Today we'll talk about Oracle performance tuning methodology, and I'll try to show you what I remember from my experience. So the topic is Oracle performance tuning. Okay. So the first thing is when do you do that? First is your SQL. Okay. So this is like your object or core. Where this comes from? This comes from app scheduled job and reporting. So these are three input. Either it will come from app, it will come from scheduled job, or either from the reporting. Okay. Now the thing is, you can question when the app was designed or when the application was designed. That time things were okay. By suddenly the performance issues are coming. So there could be 4, 5 analogy, or maybe 2, 3. Let's try to see what could be. So the practical approach, what happens is recent change. Okay. In table structure, stale stats. Okay. Stale means that I have scheduled cron tab job running in the night, and once that job completes, it gathers the stats. So gathering the stats means that the Oracle dictionary is made aware that what is the number of data, how unique the table is, what are the indexes, basically the properties or the details about the data. So once that is done, and when I run my query again, or when my query is being run either from a SQL developer, from the app, or for the web client, or anywhere, it will have the latest data, and the Oracle will try to optimize it, will try to give the optimized plan for running the SQL as to make it consume less time from a request to response. But let's assume around 11 p.m. in the night, my stats gather job runs and it gathered the detail. But after that, around 1 a.m., I got more data on my table, and it got, or either I reduced the data on my table, and then next at 5 a.m. the query is being run. It will have the detail what it was captured around 11, not at the 1, because by 1 things got changed. So it does not mean my table can't change, but if there is a drastic change, my performance get deteriorated. So this case is initial days. Generally a new setup is done, but with the time, uh, the DBA knows it based on its monitoring tool, and the DBA adjusts it accordingly so that this problem is like base minimum most of the time being taken care of. Okay. The second is that end of the day, when there is a performance problem, it will be the SQL we look for. That is the first part. The second part is how do we look the SQL? Means like if I generate the SQL, if I generate the SQL text, then how do you tune it? So first of all, what we should look for. So you have a many tools. One can have a crontab script, OEM monitoring. Look for top SQL in performance hub ASH analytics. So this is like a 13C new feature. Okay. Now, uh, okay. So you look at it. Now what happens? You get a SQL ID. Yeah, you get a SQL ID. Based on that, you get a session. Based on that, you get a SQL text. So by this time, you know what you need to look for. Now you generate an explain plan of SQL ID. So there are multiple ways. One is, since the query is already running or it has ran, so quite naturally it's it's already in a memory, the plan has value. Based on that, you can generate the last execution plan of the query which has run. So it will give you tree like structure. Okay, tree like structure, something like this, and further details. So if you set your statics label is equal to all, it will give you additional details about this thing with actual row and estimated row. Okay, now you have to see first of all what is the actual row end of the day. For an example, if you are just retrieving 10 rows and you see in order to get those 10 rows you need to scan a million rows. Okay, so you have to optimize the million rows in this part. So basically what I mean to say that you see in your plan that before you get your select result, let's say this query is of select and you have your million rows somewhere here, 1 million rows, and you're taking 10 rows. So assume that you have a nested loop join which is running, which is returning 10 million rows, and then there is a further filter on that 1 million rows, and you end up getting 10. So you have to reduce those 10 million rows. That is the first part. So once you reduce this, your overall time gets reduced. That is the part one. Your overall PGA and the temp space users gets reduced. Part two. Now how do you do that? The doing part is that either you first understand what this query is trying to do. For an example, if there is an inventory list, there is a seller list, and there is a company list, you can have a three joins in order to get which seller in this particular company sold more of the product of this quantity. Okay, so try to think how could you rewrite this query meeting the criteria of the query. Okay, that is a part one. Now once you decide that criteria of those, just try to minimize it. So you have to work on it and see if you can put some index in order to avoid the full table scan. That is the first investment or first thing you can do on the column part. Okay, so once you do that and you're able to reduce, you can, yeah, you can reduce the overall execution time. Okay, you can also enable the monitoring, go to the OEM, just check it out, you know, what's happening. So every process will give you certain detail. What is the buffer read? Is that it is, how, what is the number of execution? Is there a hard pass happening? And how could you reduce, the basic objective is to reduce the number of the rows in the where clause. Okay, that is the first thing you need to remember. So there is no formula or sentence I can say that you use this particular keyword which will reduce. No, you have to basically do a mathematical analysis after generating all the further reports of the SQL. So there are many different scripts and tools you have to dig down. Okay, you have to take the granular data. If you can go per second wise, per minute, I think these two can give you some this thing. And you can also look into the table structure, whether it is a normalized or not. So normalization means that you are trying to remove the redundancy. Okay, so if you do that, you also need to look that where your data falls in this table. So for an example, I have 1,000 rows and I'm trying to achieve read 900th row, and I'm scanning from row 1 to 900 out of 1,000. Instead I can scan from 1,000 to 900, reverse. Okay, so if you go like that way, you're reducing the time quite naturally. Okay, so that is the first part. Then you need to understand how hash join works. You need to understand how nested loop works, how filter works, how aggregate sorting works. Okay, so basically you need to understand how further index, histograms, what are those, partition and pruning. Okay, so see, you need to understand these things on a very vast level. Why what is happening at the SQL level, you need to understand this part. So you can also partition a table based on range, based on hash. You have to analyze the based on what condition these tables can be partitioned. Okay, so if you have data where you need to look for a particular month, you can go for a partition by date, range partition. Okay, if you have some random data, you can go by hash partition. So this will help you to minimize the number of the rows a query has to scan before it can return you the result based on the where clause. So now try to look how the nested loop works. Okay, and the hash join. So these two we'll try to cover here. Okay, so see what happens. Let's break down what is nested, what is loop. Basic thing. Loop is, this is one loop, two loop, three loop. Okay, so just visualize it. So loop, once you enter here, you run, you come here. Okay, once you enter, you run and come here. Okay, nested means inside this. Okay, so how it works here, you're writing for I is equal to 1, I is less than 10, I plus plus. Then inside that, for j is equal to 1, j is less than I, j plus plus. Okay, print a b c. Okay, then you close your quotes here. So naturally, for I is equal to 1, j would run, okay, less than equal to, j would run one time. Okay, I is equal to 2, j would run 1 comma 2 two time. I is equal to 3, j would run 1 2 3 three time. So in 3 runs it has already ran 6 times. Okay, so same way, I is equal to 10, j would run 1 2 3 4 5 6 7 8 9 10. Okay, 10 times. So basically what is happening, j is running 1 plus 2 plus 3 plus 4 plus 5 6 7 8 9 plus 10, which is almost 55 times. Okay, so this is j run. Okay, now I run is equal to 10. So basically total 55 times this ran. Okay, now what happened on the SQL side, it will be something like this: nested loop, table A and then table B. So this is my parent table, which is I. This is my child table, which is J. Okay. So this way, for every value of in table A, this is being propped. Okay. If table A returns in certain condition, let's say 20 values, okay, then table B would be propped 20 times. Okay, then yes, then the output from this will be sent upward to make another condition. Okay, this is the concept of nested loop. So it is said that table A should be small or the driving table, because table B scan is dependent on number of times table A is being called. Okay, this is this thing. Now let's come to hash join. So hash join is also like a nested loop, but I won't say a nested loop, but what happens, table A and table B. Okay, so it will be like this: table A, table B in explain plan. Okay, so here what happened when this hash join condition is, this is the part of the memory. Based on the condition, table A data will come here. Okay, table A data will come here in the memory. Let's say 1, 2, 3, 4, 5, 6, 7, 8, something on the hashy part. Table B data will be there in the table. Okay, this is now when this join condition is being done, data from table A, B will be matched with a table A. Data from this will be matched in from here in this. So, but this is the part of memory. Okay, where hash value of data is stored. Okay, now let's assume that for storing 10k rows, I need 5 GB memory for an example, but I have only 4 GB memory. Okay, so out of 10k, whatever gets filled in 4 GB will come, rest will be put in temp table space, assuming 1 GB of data. Now if rows from table B is able to be found in rows present in memory, then it is called optimal. If not, and it has to touch temp, then it is called 1 pass or 2 pass, depend on how much time temp was required to be accessed. Okay. So so the thing is like, which could be faster? So there is no exact answer. Nested loop can be faster. Hash join can be faster. Hash is dependent on your memory. Nested loop is dependent on your number of the rows in the driving table and the your where clause condition. Okay, I'll come with more better explanations, not on this video, but sometime later. Bear with me. And yeah, another last thing I would like to cover is like index. So how the index are stored? Basically it is said, if there are two things. One is like clustering factor, another is index. Clustering factor and the leaf. So basically, the index is like this. It's like a more of a flat. So it is like root, then it goes to branch, then it goes to leaf. Okay, so this is basically the leaf. I'm not able to draw, so your data will be somewhere here like this. Okay, and in order to reach this, you need to at least do 1, 2, and then 3 IO. So if it is clustering factor is like how evenly your data are distributed. So behind this you have, okay, let me remove. Yeah, behind this you have your table segment. Okay, table segment, and these leaves 1, 2, 3, 4, 5, 6, 7, 8, 9 having a reference of where the data are. Okay, let me change the color to this. Okay, where the data are. Okay, so if it is like evenly distributed, the clustering factor is high. If it is not, this can impact performance. So what does that I mean? That one of the row data is here, and then this leaf is pointing here. So let me change the color to some other color. One second. Yeah, and then it is pointing here. This is pointing here. This is pointing here. This is pointing here. This is pointing here. So if it is like this equivalent, if it like this, my clustering factor is equivalent. But if it is like this, or this, so this is my leaf one, leaf two is like this, and this, and then this, then this. So what does it mean? That if my scanning is happening, and if it is like this, it will be pretty much smooth. I go to this leaf, I read everything, return back. But if my clustering factor is not equally distributed, I come here, I read one data from here, then for other I go there. So I have to scan all these things. So this retrieval will take time. So basically these leaves here are the mapping point. So when it is said that you rebuild your index or recreate it, this thing does not improve. Okay, so the one option is you can do the colease, which is called colease, COLESCE. Okay, so once you do that, uh, it can help you, but you can't get out of it. Okay, and you can also use hint. So how does it work? You have to like select, and then you put your hint here, and this brushes, and then you do. So this you only put, then you get from A where C is equal to D, something like this. Okay, so this is the part you put your hand. So basically this is done like when you are like a more robust and good to know, and you have done your statistical analysis, you can hardcore your hand, to use a nested loop instead of a hash join. And even if you want to give some query more preference in terms of the parallel running query, you can just get your parallel hints there, get this query run, and just get those things. So this is more SQL, I mean to say, uh, there are other ways, yeah. So for time being, I know like it's very this thing, but just you can capture my talk, and we will more continue on this, how we are going to do it. So basically, you do this, you check. So the overall objective is, in short, how do you do a performance tuning? So the performance tuning is that also you can use the, okay, let's go. How do you do it? You get a call, you get an incident, or you get a number, or you get a ticket that there is a performance issues in the database. You go ahead and look into the database with the basic checks, like you check your alert logs, you check your logging session, you check v dollar resource underscore limit, you check any long running session, you check any number of active your number of active sessions, you check any aura error. So you did all those things, and you see, like, and then you come to know there is a problem with the specific set of user or something. You go to your OEM, you check for your database, open your database front page, and then in that you go to the performance of, you go to the ASH analytics and just check for the top running queries. Once you check the top running queries, look for basically the graph. Is there a wait, is there a user IO, or is there a CPU IO? So if it is user IO and CPU IO, you should be good overall from the system point of view. But if you see a wait which is coming as a concurrency, or yes, that is the area of concern, or administrative, that is the area of concern. Administrative can false for if some RMN job is running and has not been completed and there is a wait. Because of that, concurrency can comes with that there is a problem with the SQL users. Now you go to the top SQLs, click on it. Once you click on select, you can get the SQL ID. Open your SQL ID, check the explain plan, and see how many rows are written and where it is struck. And from the V dollar session long of take V dollar session and the V dollar SQL, based on that SQL ID, take the session ID of that particular SQL from where it is running. You can either ask a user to, hey, just stop it, do not run any reporting query in the daytime. If you see this is an application